Hello, everyone, and welcome to another SD Times live webinar presentation. I'm Dave Rubenstein, Editor-in-Chief of SD Times, and today's topic is the reality of AI in engineering. As we've been covering in SD Times, the adoption of AI is rapidly increasing, but organizations are struggling to move from project experimentation into production. Among the challenges they face is the avalanche of AI-generated code that must be validated and secured, making sure AI understands the context around the code, while integrations with data stores and other APIs are growing more complex. According to our speaker today, Plandek Chief Operating Officer Will Lytle, as you can see, the difference isn't the tools, it's how they're applied within the system. He'll let you in on what high-performing AI teams are getting right and how to eliminate bottlenecks that stall or even prevent positive delivery outcomes. Before we get started, I just have a couple of quick announcements. First, today's webinar will be followed by a live Q&A. So if you have any questions, you can ask them in the QA tab at the bottom of your screen, and we'll get to as many of them as time will allow. Second, the webinar is being recorded and will be available for review or sharing on the sdtimes.com website after this presentation is over. And now to get us started, here's Will Lytle.
Thank you very much. Thanks everyone for taking time with us today. I'm going to go ahead and share my screen. As David mentioned, we've been working with a number of organizations really over the last couple of years as many have come on to different stages of the AI journey. Some of them still very much early days, and some of them pretty well evolved in terms of having a real transformational effect around their engineering organizations, their product organizations, and how they're bringing product to market and bringing it to customers. Over the last 6 months or so, we've been doing some polling across a large group, about 2,000 different teams, engineering teams, kind of tracking how our organizations managing this transition. And so one of the things that has become kind of really important for us to focus on today is what we're seeing in our data is really adoption is now almost universal. So if we go back to November of 2025, we asked the question sort of across what proportion of your organization have you rolled out AI today? And back only about 6 months ago, about 30% of those respondents had said that they had rolled out AI across about half of their engineering organizations, or at least half of their engineering organizations. When we ran that exact same poll just 1 month ago, that number had jumped quite significantly to 93%. And about 48% of those have rolled out fully, up to about 90% or more across their organization. And that's up from 12%. So what we're seeing really across our customer base, as well as the research that we've done, is over the last 6 months, there has been a really, really, really big push to drive AI adoption and roll out across the organization and get engineers, product owners, product teams using AI in different facets of their role today. Now, one of the things that's really interesting about this is how exactly that usage is shifting. Right. So this, again, is a very similar poll we looked at all the way back and kind of how are you using it between sort of an ask sort of questions, sort of think chat GPT mode, to assistant, sort of a pair programming mode, to using it, using agents, deploying agents in more of a supervised mode, as well as autonomous agents. And so what we've seen in just the last 6 months alone is quite a significant shift away from that traditional chat GPT asking mode into utilizing it first and foremost primarily as an assistant in pair programming, but quite a significant jump around the way that organizations are actually deploying agents within software engineering. Now, this is supervised, so obviously we're not talking about agents running autonomously, checking, creating code, merging that code, and so on. We're talking about developers using orchestrated agents in a way that they're able to build product and bring that to customers to market today. Now, one of the things that we talk a lot about with our customers today is, whilst you see a huge amount of adoption use of these tools, right, there's a real perception that the adoption use of these tools by engineers is immediately going to translate to faster delivery. MIT last year ran a very interesting survey, really kind of touching upon this, where they looked at, experienced developers that took it, about 19% of them or sorry, 20% of them felt that they were faster, but about 19% in reality, when they looked at it from a systems perspective, how long does it take those teams in which those senior developers are working to deliver, was about 19% slower. So it's a real perception gap of around 40% that you're probably starting to see in a lot of organizations where, as an individual contributor, as an engineer, I can feel that code is actually these tools are actually making me generate code, run tests, be able to be more productive at an individual level more efficiently. But actually, how that translates to us as an organization, as a team, being able to deliver software faster, it actually has quite a slowdown effect. Now, this ultimately comes down to what we think about when we think about sort of system level constraints. And so when we look at the adoption and use of tools, it's quite clear that AI is able to drive individual performance, individual productivity at a much more significant level. And sort of orchestrating task execution, the tools are very good at. When you translate that to a complex ecosystem of how developers work together, engineers work together with product teams to actually deliver software to production, more often than not, we see that things are slowing down. And it's because AI doesn't fix the team, right? AI really amplifies what's already there. And so a helpful way of starting to think about it is, how do we start to think about this transition to AI augmented engineering, utilizing more systems thinking, and in particular applying the theory of constraints rather, to understanding how teams are operating, where bottlenecks are starting to form, and how those bottlenecks are starting to shift fundamentally throughout the SDLC and even up into the PDLC. And it's really understanding that allows organizations to drive a real change and a meaningful change in how they're starting to deliver software. So why are AI gains getting absorbed? Well, individual output is going up, right? You can see that in a number of different metrics, in different ways that teams are evaluating it. But your delivery performance, what you're actually delivering, how you're delivering that, is more often than not remaining flat. And it's not because engineers are not finding more effective ways of utilizing these tools, but essentially what has historically been a capacity level bottleneck, or bottleneck that's been realized at an engineering level, is shifting now in the SDLC. It's not disappeared. So we look at the output metrics that have typically been used, and whether that's PRs, commits, lines of code, stories complete, tickets complete, and so on and so forth, those have always been a poor proxy for demonstrating acceleration of value delivery, and AI really is starting to expose this. Instead, we're starting to see those bottlenecks sort of shift. So AI is accelerating how individuals are delivering, but the constraints are now shifting to review cycles, planning, dependencies, ideation as part of the PDLC, as well as other elements, part of your continuous delivery and continuous integration ecosystem. So parts of the system really that AI has yet to have a direct influence on. And therefore, the gains that you start to see from an individual perspective start to be absorbed by that system. I can develop code much faster, but fundamentally, if I can't do anything to materially change how we ship that code, then there's no way we're actually going to deliver faster. And so a lot of today's conversation is really going to be focusing on that the problem is not measurement as such, but how you're starting to think about it being a system level problem, and starting to look at the right layer of the system and evaluating how you're building software from a system level, and how AI is and isn't starting to have influence on a system level. So one of the things that we've kind of historically used over the last number of years, and we've updated it this year, part of our 2026 revision, is what we call our 4 pillars of productivity. Now, the 4 pillars of productivity start to answer the question around, how do you think about and measure productivity in software engineering? So it's kind of agnostic of AI at the moment. Just think about it more fundamentally as a question around measuring productivity. How do we start to think about productivity? And for us, it really comes down to these 4 different elements. One is focus, because ultimately, as software engineering organizations, we put a lot of investment into our teams and into the tools and technology that we use to build our products. And we want to make sure that that investment is being pointed to the things that are going to help really drive our business forward. So whether that's driving new revenues, digging a deeper moat around existing revenues, or driving customer satisfaction, we want to make sure that we're optimizing our investment, our engineering focus, our engineering capacity, are things that are going to be moving the business forward. So it's really important to understand the proportion of time and effort that we're focusing on value delivery, but also as a subset of that, then understanding, or a counterpoint of that, understanding what proportion of our time is actually being focused on things like support and maintenance, right? Next is kind of your traditional flow metrics. So we want to be able to drive a highly efficient flow state within our organization. So looking at your traditional metrics, lead time to value, cycle time. 2 things that we've introduced this year as part of our 26 benchmarks is the throughput and PR quotients. And what these do is they look to normalize throughput by taking throughput, dividing it by the time it takes to drive such throughput, and ultimately then normalizing that by dividing the amount of developers that you have working within a particular team or a particular product area. It's not meant to be a silver bullet as such, but what it is helpful to do is start to normalize throughput in a meaningful way, both either in terms of value or PRs, but also then set the scene as we start to move through a transformational effect of how we deploy agents and start to reshape teams. How do we then start to have a more useful measure of thinking about and talking about the impact that these agents are having on the way that we're able to deliver? Time to merge PRs and merges per dev per week are also two kind of really important ones. Predictability, again, this is very much around how are we driving good reliability and consistency across our organization when it comes to a team being able to do exactly what they say to do, or to aggregate that up into squads, tribes, and so on and so forth within an organization. So delivery aligned with our customer expectations. So whether that's sprint capacity accuracy, sprint target completion, scope change, or velocity volatility, these metrics will allow you to canvas across both Kanban and Scrum teams to be able to understand, the heartbeat of that organization around that team being able to drive good, consistent delivery, and how that then marries up with how you're delivering against expectations that you set with your business or with your customers. And lastly is quality. So quality isn't just about building a quality product. Obviously, we're a SaaS business. We want to build a quality product for our customers. But it's really about understanding that there's a really important value exchange decision point that's made on a regular basis by teams. And if you think about, every time a bug is raised or a defect is raised within your system, the longer that bug or defect spends in the backlog, the longer it's going to take for a developer to fix that once it eventually gets back to them, right? The code base has moved on, the context has changed. So what I changed in the first place and how that's influencing what I could do, what I need to do to actually resolve the bug may not take me 15 minutes, which it would have taken me had I had immediate feedback from our QA team or from the automated tests. It actually may take me a number of hours or VRs. And that time, that extra time that's spent there, is time specifically that's taken away from the things that actually matter most for a developer, which is actually driving new features, new functionality, new things to our customers, and making them more satisfied, happier. So each of these metrics around the quality side really not only capture the element of how are we building a quality product, but what does that mean in terms of us being able to drive fast feedback loops and really optimize the amount of time that we're investing maintaining the quality of our products. And that then correlates directly back into not only value delivery, but the support and maintenance side as well. So what's really, really important from a system perspective when we start to think about the impact of AI is that organizations really have set out, before they even start worrying about the tools, an answer to how do we measure productivity? How do we think about productivity? How do we communicate productivity both downwards as well as upwards to our boards? And this 4-pillar system allows you to not only have a good understanding across different core elements of software productivity, but then also allows you to be able to reference and compare those to broader industry benchmarks, answering the questions of where are we doing well, where are we not doing so well. These benchmarks allow you to get a better understanding, relatively speaking, of how the engineering team is performing, whether it's an individual team or more aggregated throughout the organization. These are really kind of critical points for you to focus on. Now, you'll notice as well, I've dropped a couple of QR codes along the journey here. So obviously, if you're interested in downloading the latest industry benchmarks or some of the other materials that we've seen earlier or further down in there, please feel free to click on that QR code and you'll get access to those guides and that research straight away. Now, one of the things that we've really noticed over the last 6 months is where is AI actually starting to drive change? So we've separated out teams that are using AI within our platform, as well as teams that are not using AI, to kind of separate out how do we see any differences in how those teams are performing vis-a-vis our industry benchmarks. And a couple of things have really shown through. Number one is that teams that have typically been your lower performing teams are definitely benefiting the most from the adoption of AI tools. So lead time to value, which represents how long it takes us from idea to production, cycle time, which is a subset of that from dev start to production, both of those are seeing significant gains from the bottom quartile, right? The top quartile as well are starting to see equal gains, but at this stage, it's more of a marginal gain as opposed to a transformational effect. Now, what's also interesting, though, is the sprint capacity accuracy. And so this represents a team's sort of ability to plan consistently and accurately against the capacity that they have and minimize the amount of either over planning or under planning as they're moving into each incremental initial cycle. AI hasn't had a significant impact on that, but we have seen that AI has started to have a pretty big impact on the quality side. So when we talk about the speed at which these bottom quartile teams can deliver, what we're also then seeing is actually they're able, within that particular time frame, able to deliver more stories, more value to customers with a relatively managed quality side of the back of that. So 200% increase in the amount of value that they can deliver per customer compared to the bugs that are raised on the backside of that. Okay, so we are seeing additionally some quality improvements, but again, really being driven by the bottom quartile. Now, why teams fix the wrong bottleneck? And so what we focused on so far a lot is the quant data. Okay, and the quant data will tell you very effectively where is the system slowing down. So if I think about our lead time to value, and I can actually demonstrate and lay out the entire flow of our system from idea all the way through to production, I can start to see exactly where bottlenecks are forming or how they're starting to shift. But the one thing I can't really tell is the why, right? It points to the system and not the cause. So more so and more so, we're trying to push a lot with our clients today that the real ability to identify constraints and the movement of constraints within your SDLC is to combine both the qual and the quant data, because the qual will tell you the what and the qual will tell you the why. Why is the system zoning down? What is the context that we need to understand the patterns of this data? And once the quant finds a signal, the qual traces it to the source, right? And we're seeing more and more as teams are starting to optimize different elements of the SDLC, that dependency is moving further upstream, whether that's capacity sizing for engineering teams, or whether that's going into the PDLC in terms of the flow of new requirements, new features that are coming through the product team. Those constraints are really shifting between different areas of the SDLC and PDLC. Now, one of the things that we also launched at the end of last year is, well, I guess a little bit of context for this first. There's been a huge amount of marketing out, whether it's GitHub Copilot or Anthropic or ChatGPT, a lot that's been pushing around this concept of buy AI tools and drive 10x productivity, right? And I think every software engineering leader, whether you're a CTO or VP of engineering, knows that it's not really that simple. I don't just buy a bunch of GitHub licenses and then achieve 10x productivity overnight. It's a lot more complicated than that. And so what we did is a way of not only helping organizations understand how to more effectively move through this transition, but how they can use this structure to be able to communicate, or framework to be able to communicate not only downwardly within their organization, but upwardly, whether it's at the exco or the board level, what we call our RACER framework. And the RACER framework really kind of moves you through 5 steps of trying to think about how do we drive this transition to AI augmented or engineering. Number one is just the rollout side. Okay, we've invested in a number of different licenses. Are we using them? How are we using them? The approach side of things is really focusing on how are we deploying these tools, and are we using the right tools with the right use cases to be able to set ourselves up to be able to maximize individual level productivity. Now, the constraints, and this is where we're going to spend a little bit more time today, is looking about how do we identify and systematically eliminate the barriers or bottlenecks that are slowing us down, the things that are stopping us from being able to translate individual gains into system level gains and being able to really then change how we deliver software to our customers. Engineering impact, and so that's giving yourselves the ability to use some sort of a framework. It could be the 4 pillars or however you want to do it, but some framework of productivity, so an understanding of productivity that allows us to evaluate over time. Here's where we were in the past. Here's how we're changing. Here's how we're not changing. And how do we evidence ultimately the impact that this is having on system level productivity? And then lastly, results, which is really about how do we communicate how we're achieving business outcomes, particularly around the ROI. So today's conversation is really going to focus on constraints. So what I'm going to talk about first is what are the 7 most common categories of constraints? So again, if we think about, let's think about a very extreme example here. If I'm a software engineering team, and let's say I've bought a bunch of Cursor licenses or Claude licenses, and our team is starting to use these tools, starting to see real benefit from these tools, at the end of the day, if we're only deploying to production once a month, we're never going to be able to fully realize the value that these tools offer. In fact, if anything, the releases that we're shipping into production are going to be far larger and far more risky. So how do our clients today start to think about and categorize constraints so that they can systematically start to address them and eliminate them? So the 7 here, tooling, sort of the obvious bit here. There's code base and architecture. So to what extent our code base or architecture design is limiting our ability to run automation, parallelization, and utilize these tools more effectively, especially if, I think maybe less so these days, but certainly going back 6 months ago, some of the LLMs were much more effective with certain code bases, certain languages than others. Documentation, so how AI tools and humans can access the context they need to be able to run in more automated fashions. This is particularly important within the agentic world. Workflow and process. So again, if you're working in a highly regulated environment where you have a number of checkpoints that you're going to have to go through, those can create unnecessary is a relative term. Those can create bottlenecks from an engineering perspective that stop us from actually being able to deliver faster, even though we're able to ship more into those decision gates. One thing we'll talk about this in a second, becoming more and more relevant to our clients is governance and compliance. So, particularly if you're working within the banking or regulated section, perhaps you have an organization that's incredibly risk adverse from a cultural or historical perspective as well. How do your policies of governance compliance within your organization potentially slow down innovation? Training, which kind of goes hand in hand with culture. So it's about making sure that the teams understand and can use effectively these tools, but also can cross-pollinate success stories within the organization so that they understand it. And then culture. And this is probably one of the bigger points that most organizations face is how are people on this journey, right? How is leadership buying in both internally, but how is our teams within actually, who's adopting, who's not adopting, how are people kind of transitioning along that journey to AI? So with part of this research that we did, that we've done every single month, this is also a question that we've asked. And so if I compare back again, November to last month, what we've seen is, and this may not surprise many people on the call today, it didn't used to be the case, but certainly governance and compliance has now shot up officially, and workflow and process have shot up the most in terms of being the leading reasons why the main constraint categories the teams are facing today. Cultural had typically been the leading one, and it's kind of moved back a little bit. I think there's a number of reasons for that, particularly time and teams getting used to using the tools, finding success stories, and maybe what was initially a bit of a shock to the system, they've started to embrace them and understand them a little bit better and use them in daily lives in more productive ways. Code base and architecture as well has shot up significantly. And that doesn't surprise us at all, because I think once you start to move through the initial learning and training on how to use these tools, that is then going to shift to ultimately the biggest systemic and arguably the most difficult one to change, which is the code base and architecture within which you're working. Okay. So those have been the 4 major ones that we've seen grow. And you look at the right-hand side of this, you'll see 16, 38, 17. That's the growth in percentage points over the last 6 months alone. So they're quite significant in the way that they're starting to hammer out teams. So how do you address these? So we put together a 4-step constraint elimination process. And a lot of this is taken from our conversations and working very closely with our customers to see the ones that are really transforming their organizations, the ones that have shifted from, historically the sort of traditional development teams into a one product owner, one senior engineer, and a number of orchestrated agents. How have they been able to tackle this? This has come through a lot of those. So one is about the identification. We've spoken about this a little bit already, but it's identifying what are the signals that are showing you exactly where your constraints are. And those come from both quantitative signals, so looking at and being able to interrogate things like your cycle time, lead time for changes, PR. So these are your traditional KPIs and SDLC metrics that you're probably used to using on a regular basis, but also combining that in with qualitative signals. So developer frustration, surveys that you're running that capture some of the retro themes, stakeholder feedback. Oftentimes what you'll find is developers will very clearly highlight the reasons why you're starting to see, for instance, one aspect of your cycle time slow down, let's say the queuing for QA stage of your process. They'll be able to add a bit more light and a bit more flavor to exactly why that's happening. So it's important to bring those two together. The next is categorizing them. So actually putting them within each one of the buckets. from a resolution perspective, how you burn these down, it's not necessarily essential. But if you step back, especially within larger organizations, it is incredibly impactful to understand which of these categories are actually driving your biggest constraints at a macro level, and then being able to use that information to be able to communicate outwardly, whether again it's at the exco level to other key stakeholders within the business, perhaps your CPO or the CRO, ultimately into the board. And so this provides certainly CTOs that use this with a very good structured approach to being able to manage expectation of, why have we bought some licenses last month, why have we not seen 10x productivity? You then have a much more structured conversation around where the actual constraints within our technology business, whether that's architecturally related, people related, workflow related, and so on. And then it allows you to then set up the next stage, which is how do we address them? Okay, so building a constraints dashboard, whether it's in a tool like Plandek or even if you're just using Excel, what's really important is to then start to not only measure these things but bring them into view so that you can discuss them, come up with how do we resolve these. You can work on multiple constraints in parallel. Our recommendation obviously is to always focus on the highest impact. And so to regularly socialize this with stakeholders. And then as part of any kind of continuous improvement program, really to repeat that. So driving continuous improvement cycle, evaluate the metrics, pivot when needed, and really the organizations that have obsessed about this, that have really taken a systematic approach to whether you're using Jira or ADO or Linear, setting up specific issue types that identify and capture the constraints, putting them in a backlog, and then having teams burn down a backlog of constraints alongside the backlog of work that they're typically doing. That is how you're going to ultimately get through and drive through and obsess about how you're going to resolve these constraints in the system. So what do the best teams do differently? From the conversations that we had today, the ones that are leading the charge, no doubt, start off with measuring the system before they're worrying about deploying the tool. And you might not be able to benefit from that. Again, as the data shows, the far majority of organizations that we've dealt with today are using Gen AI and agentic AI tools at a significant amount within their engineering teams. But you should be able to kind of sit back and say, okay, we want to baseline exactly what we want to measure, and then use that as a way of being able to understand, as we optimize individual use of these or different areas within the SDLC, what impact is that having on our overall flow and our ability to deliver at market. They treat qual and quant data is equally important. So it's not about using a tool like Plandek to capture some of the quant data and then running surveys out of Google Forms over here and dealing with them separately. It's really bringing them through together, right? Having we can use machine, there's a number of things that you can use to process that information. How do we bring that data together so that we understand the qual influence in the quant and the quant influence in the qual? More and more, we're starting to see teams looking upstream to the PDLC as the engineering metrics start to degrade. Okay, and that's kind of a really important point, because as you optimize the SDLC, naturally you're going to alleviate or minimize the dependency on engineering capacity, and therefore what we build and how quickly we can then push that into engineering becomes far more important. And then same approach around thinking about the PDLC and what are the constraints within the PDLC becomes equally important. And really good teams, the more that they do this, have a really unique ability to anticipate where new constraints will form as the output velocity increases. Okay, so if we resolve one constraint, where will the next one evolve? We like to think about this sometimes as whack-a-mole. Obviously, if you grew up in the States, you're very familiar with that from any arcade. But as you resolve one, you're not going to necessarily see a material change in your SDLC. The fact of the matter is, you've resolved one, that key constraint may shift to another part, which may then shift to another part, and teams need to continue to obsess, and organizations need to continue to obsess about how do we burn those down. And ultimately, what I think you'll start to see is not only will you have a feature level roadmap, but you'll also have a roadmap that really captures the constraints in the system that are going to be equally important, if not more important, to accelerate your ability to get value from some of these tools. So what's the kind of takeaway for everyone today? Really, number one is, and kind of cover this again, how are you going to measure the system first? How are you going to measure productivity? So utilizing something like the 4 pillars and being able to use that against market benchmarks is a really, really valuable tool for you. How do you combine the qual and the quant data to get a more accurate diagnosis and start to see the constraints are rarely where they first appear. So being able to combine this data together will give you much better understanding, not only of where the initial constraints exist, but as you minimize them, how and where they shifted into the SDLC. Identify which constraints are limiting delivery today. So eliminate them in the order of impact and anticipate where the new ones will form as your AI increases output velocity. And I think probably the biggest thing, the most important thing, it's a little bit of a side bit, but I think organizations that try to play out this transformational change as a big change management program oftentimes will be a little bit slower to get through it. Where we've seen the biggest impact with our clients today are those organizations that have really tried to change the operating model, see what works, what doesn't work, and continue to operate. So it's really about driving speed and pace and a very, very tight feedback loop and how some of those changes are impacting teams, impacting organizations. But I would say lead with the change rather than trying to change manage everything over a 1 year, 2 year, 3 year program. So that's a kind of a whistle stop tour through a lot of what we wanted to cover today. I'm just going to pull this up for a second, but I'll invite Dave to come back in and carry on the next Q&A part of the session. Dave? There he is.
Yes, here I am. Yeah, that was great. So I wanted to just remind everybody, if you have a question, to put it into the Q&A tab, which is at the bottom. I see we have a question already, Will, and this attendee would like to know, could you talk about how respect, trust, and human debt are important to engineering with AI?
Respect, trust, and human debt. So I think trust is, it's not something that we call out specifically here, but it's something that's implied within the qual element of what we're talking about. And trust, I think, it's an interesting topic and one that we've talked to a lot of CTOs about, because there are kind of two elements of trust. There's trust that can be influenced and trust that may or may not be able to be influenced. And I think there's some of our clients that take a pretty bullish approach to spending a bit of time, I guess, trying to build trust and familiarity with training success stories and trying to be able to demonstrate where these tools can add value and evolve the way that engineering teams work and product teams work to deliver software. And then some elements of trust, which I think are very difficult to overcome entirely. Okay. And what I mean by that is, I think having fundamental trust is important for teams being able to move the needle and actually drive adoption and get value from these tools. That is not to say that everyone will always come on that journey for a variety of different reasons. So I think if you're a technology leader, it's important to be able to recognize, make an investment into building trust through training, familiarity, success stories, hackathons, etc. But also recognize very quickly where trust is not something that's going to be delivered across everyone, and being able to pivot and move as and when you need to directly with that. On the human debt side of things, I guess before I answer that, I would want, David, do you have a context of human debt? It's not something I'm...
Well, this was a question from one of the attendees. If he wants to elaborate on that in the QA tab, we could address that. In the meantime, was there another poll that we wanted to launch, perhaps, and talk about those findings?
Yeah, I think there was one poll that we were meant to launch in the beginning, I believe.
There it is.
Yeah. Excellent. So we did want to put the poll up for everyone, to give everyone on the call today the ability to kind of answer some of the same questions that we went through earlier as we look through some of those slides. So I'll give everyone a few minutes to go through this. In the meantime, David, is there another question possibly from the Q&A?
Well, the explanation of human debt came in, and okay. It is defined as in this question that human debt occurs when people don't speak up. So I'm not sure where he's going with that.
Yeah.
Perhaps it's just about, making sure everybody's on the same page, working together, pulling in the same direction, all those kinds of things. And, speaking up when they're seeing problems or issues. That's how I'm taking it.
Yeah. I think, and there's probably another element to that as well, which is people not speaking up about being hand in hand with the kind of trust element, that they're not raising their hand about not feeling fundamentally safe in the transition. So I think this is where, I mean, certainly from what we've seen, where the surveys run correctly with the right cultural element around it for the business can be very effective. It's starting to elicit, move the needle on trust, but start to then minimize the amount of, as you say, the human debt from a number of folks being silent within the organization. Um, yeah, I'm that's probably as far as I would go into that element.
All right. Okay. Well, we're starting to get some people answering the poll. We'll give it another couple of minutes to have more people fill this out. It'll certainly give it a little more meaning. So just wait for that for a second. One of the questions that I've always had, and I'm hearing this everywhere I speak with people in conversations that I'm having, this gap from experimentation to production. Why does it work great when we're playing with it, but as soon as we try to get it into production, it's a fire drill.
Yeah.
And I know you talked a lot about that, in the presentation, but I'm just curious to know, like, what would you see as that biggest bottleneck? We're always hearing about the bottleneck that's hurting people trying to go into production with these things. Where do you see the biggest issue there?
It's a good question. So with, I still think the biggest issue from an overall perspective is the cultural element, right? And we spoke a little bit about that. From a technical side of things, it's quite difficult to argue. It's quite difficult to discuss too specifically because of how varied, obviously, a number of people's architecture and challenges are from an architectural and code base. However, one of the things that I think is really important is to be able to map out the dependencies from right to left if you think about the traditional model, and being able to understand what context am I giving a lot of these agents in a way that they can actually produce something, which when it does hit a developer, it's not throwaway work. So that we're not building throwaway prototypes, but we're building prototypes that are utilizing component libraries, that they're utilizing security policies. And so I think, if you look at what should exist in engineering, you should have very robust component libraries, you should have very robust um, development policies, security policies, all written out. Over time, these things tend to fall by the wayside, they tend to become unupdated. And the agentic world is now really driving a lot more focus in evolving and updating these policies so that, as a product person, if I'm starting to build up, I think putting more onus, one thing I'll caveat there is putting more burden, more focus on product folks becoming more product engineering oriented. Don't have to be actual expert in developers, but they
Mm.
need to be able to work with these tools to be able to generate functional prototypes that work within the guardrails of component libraries, security libraries, etc. So that when it does move in, you have a much better chance of being able to take a mature level prototype, evolve that, and make it production ready. Our business, we've had to go through quite a journey on that element over the last year or so, because obviously it's not necessarily easy to just have those component libraries, etc., in place. But at the agentic side, once you have all those in place, it makes a material difference in terms of what product teams can produce, and therefore what the engineers can pick up and how the agents are working within that constrained context to be able to then build something which is reasonably production ready. It also
That's
depends a lot on how those applications are broken down so that you can minimize the burden on on agents having to build very large complex components as opposed to being able to build very specific, very tight, very well defined areas within a much more modularized architecture.
excellent. Excellent. So I was just looking at the poll that we pushed out, and it's interesting to see that there's still that wide spectrum of you have people who've adopted AI and are implementing it widely across the organization, and a few that still just are kind of putting their toes in the water to kind of see where there's at. I guess that would be expected with any new technology, right? You always have the first movers, and you have the people who want to
Yeah.
be cautious and make sure everything's going to work before they implement it, right? Is that what you see out there as well?
Yeah, and it was moving kind of slowly and steadily. It's really over the last 6 months that we've seen it really shoot up. right? And I kind of talked about that on the first page. We were really quite shocked, quite frankly, recently when we've seen it,
Right.
that 93% had now had it rolled out across more than half of their organization, with 48% um, uh, being at 90% of more of the development teams. That hand in hand with the fact that there's been a very, very, very quick transition from the ask mode, so kind of conversationally, how would I do this, what does this script look like, can you check this for me, to working in much more of a paired model and seeing a huge explosion in the agentic side was really, really surprising to see how teams are now moving at such pace, not only in terms of the rollout across the organization, but more use of agents. And I think broadly speaking, we don't poll on this, but broadly speaking, I think this has a lot to do with now trust is starting to really be built up, confidence is starting to be built up in how these tools can operate, but also how they can't operate. And engineers are starting to feel more comfortable and more familiar with the prompting language and how to utilize these tools to get the right sort of outcomes. So it's less of a threat, less of a hindrance, more of a now mastery and operational mastery and how to actually utilize these tools more effectively. So we see more of our clients today shifting to that type of a new team model and actually building out production grade code, even in industries where you would think might be lagging, like health tech, where there's a lot of regulation, a lot of risk management. We've still seen a huge shift of those customers moving into that transformational model. So I don't know if that answers a specific question, but yeah.
Oh, that's what we're seeing as well.
Yeah.
So we do have a couple of questions. We'll get to those, and then we'll be right up against time. One of the questions is, do you think the performance of Claude Code has driven the rapid increase in teams using agentic AI for coding?
I, I, I got to be careful how I answer this because I'm not trying to push for Claude, even though we do use Claude internally. Um, I think the answer is yes. And I think it's in part because of what Anthropic has done, but also I think it's coincidental with two things. The LLMs, whether they're Anthropic LLMs or others, have really, really, really evolved over the last 3 to 4 months
Mhm.
in a way that makes it easier to drive confidence in utilizing these tools. Um, I also think that there's a natural, as adoption goes up, that trust goes up, and you're kind of starting to see a coincidence of LLMs improving, the trust levels improving overall. And I do think, although this has not been researched in any stretch of the imagination, so please just bear with that, I do think Anthropic has done very good to build an agentic interface and IDE that was much more similar and closer to how developers have used to operate. And
Mhm.
that certainly helps in that trust and familiarity. I know there are other tools out there, I won't name them, which have built UIs or user experiences, which are a little bit more foreign, and they've struggled to drive real adoption and use from the engineering community. And if you're struggling with that, then it's hard to then think how we're going to then move to more of an agentic model, because I think you do need that trust and adoption and buy-in from the teams before you really, really start to then operate in an orchestrated agentic way. So I think Ken, it's a good question. I don't know if it's, I think it's probably in part Anthropic, but also in part the LLMs, as well as just the general trust and confidence that's being built across the engineering community now compared to maybe 6 months ago or definitely a year ago.
Mhm. And finally, someone wants to know if there's a direct link to the AI adoption and impact benchmarking report.
Um,
Is this something we can put in the chat or?
I don't know. I don't have it offhand, annoyingly. I don't know if, is it gone in there?
I can drop it in the chat if you want.
Yeah, I mean, if you've got one, that would be fantastic. And
Yeah.
obviously, um, you can always contact me on LinkedIn or anything, Will Lytle, if you can't get through it, whatever. We're happy to send it through to you. Probably easier to remember that than my email address, but basically the same thing.
Excellent, excellent. All right, so this has been Will Lytle, COO at Plandek. So this was excellent presentation. I'd like to thank you for doing that, and obviously for Plandek for hosting. And I'd like to thank our attendees, as always, for joining us on these events. And until next time, I'm Dave Rubenstein, Editor-in-Chief of SD Times. So long for now.
Cheers, Evan. Thank you.